When people say the model, they may mean the weights, the training recipe, the serving setup, or the full product. These are different parts of one system, and changing an outer part can change behavior even when the weights stay fixed. A modern LLM is built with a training stack and used inside a production stack. On screen, the weights sit inside the recipe that created them. Serving wraps the checkpoint, and the complete product wraps serving. A model checkpoint contains the weights, while behavior comes from the stack around them. I'm Mehrdad, and this is the Transformers and LLM Systems course. We begin with representation, where text and images become sequences a model can process, and then open the transformer itself. We study transformer architectures, the transformer block, attention, and key value, followed by mixture of experts, long context, and multimodal systems. The course then moves through inference and generation, pre-training data, efficient training, supervised fine-tuning, preference optimization, and reasoning-focused post-training. The final modules connect these foundations to retrieval, tools, security, evaluation, cost, and stack selection. Our goal is to understand the ideas well enough to read the research and the engineering choices well enough to build and ship. Architecture is necessary, but it is only one layer, so today we draw the complete map. If this course is useful, like the video and subscribe for the rest of the series. First, separate the model checkpoint from the product because they are different parts of the system. A model checkpoint is the saved weights and settings loaded when the model runs. It carries what the model learned, but it does not define the full experience users receive. The product also decides how much computation to use before answering and whether to run an agent loop that acts, checks the result, and continues. Under that loop, a harness holds tool definitions, memory and state, checks, safety rules, evaluation, and the stop policy. Products such as GPT-5 and Claude make this difference easy to see, but the same idea applies to open-weight models. One checkpoint can support different ways of answering, so the surrounding system determines how its ability is used. Now move from the parts around a checkpoint to the 6 production layers that shape its behavior. Reading from the bottom, data determines the examples the model learns from, while architecture determines its structure and learning capacity. Training and post-training use that data and architecture to create a checkpoint with specific abilities and behavior. Inference determines how the checkpoint produces an answer under serving limits. Knowledge and tools determine which outside information and actions the model can use, while evaluation determines what we measure and what can be released. A problem can begin in any layer, which is why the figure places one small failure marker beside each one. The title showed which parts surround a checkpoint, while this slide shows which layers shape behavior. Next, let us look more closely at inference. Take one checkpoint and keep its weights fixed while changing only the settings used to serve it. Sampling and temperature change how the next token is selected, while a computation budget controls how much work happens before the answer returns. Stop settings and maximum tokens determine when generation ends. Together, these controls can change response time, cost, answer variation, and faithfulness, and one control can affect several results at once. Tool access is separate because it belongs to the harness and the knowledge and tools layer, not to this inference example. Before replacing a checkpoint, use the stack map to ask whether the behavior came from its weights or from the settings used to serve it. The course follows the stack in 2 broad sections, beginning with how a modern model represents inputs, computes, and generates. Foundation starts with tokens, embeddings, and position, then compares encoder-only, encoder-decoder, and decoder-only models as different ways to use a transformer. We open one transformer block and study attention before asking how mixture of experts, long context, and multimodal inputs change the design. The inference section then follows the model while it serves requests, covering prefill and decode, sampling, structured outputs, key value, compression, and context engineering. Together, these modules explain how the model is built and served. The second section explains how a checkpoint is created, improved, connected to outside knowledge, and checked before release. Training covers data and scaling, efficient distributed training, supervised fine-tuning, and parameter-efficient adaptation. Post-training covers preference learning, test time compute, and modern reasoning methods. Knowledge and action covers production retrieval, tool calling, agent loops, and the security rules around those actions. Production brings everything together through evaluation gates, cost, routing, and stack selection. Across these modules, we keep asking two questions. Which layer produced this result, and which layer should we change? If this opening lesson was useful, subscribe to Multi-Agent Academy and continue with the full Transformers and LLM Systems course. I'll keep sharing evidence-backed lessons on representation, architecture, training, post-training, inference, and production LLM engineering. You can also connect with me on LinkedIn. Thank you for learning with me, and I'll see you in representation.